Okay, what we've got here today is the question 12i. As you can see on the board, it's the little Johnny hanging on the end of a basketball hoop. And this kind of question is called a force couple. It can be found on page 62 of your purpley blue and yellow Copeland text. An exact similar example is on page 65-66. What we've got here is a basketball dude, I like to think it's Michael Jordan, coming up for a slam dunk. And as he dunks the ball, like this, he hangs on the end of the ring. What happens is his full weight is on the end of the basketball ring, here in this case, which is creating a force, as you can see there in the free body diagram and also the space diagram. The one on the right, this one, is a free body diagram. Okay, and there is only one bolt in the wall. Let me see if I can bring up a pen. Okay, what is going here is there is a bolt. The question says he hangs on the end of the basketball ring, which is here, Johnny, and on the end of the ring, creates a force reaction. And there is a single bolt in the wall. That single bolt is this one here. Okay, there's only one bolt. This black business, this black stuff here, is the actual ring that you can see on this side. Okay. It's going to pivot around the bottom of the bracket, the same as this picture. Okay, and the bolt is the reaction force. Okay, let me go to the new slide and we'll kick it off. Okay, in this example, I will write in blue pen. Okay, in this example here, I've got little Johnny. Okay, let's first work out what our knowns and unknowns are. We know, knowns and unknowns. I know Johnny weighs M equals 85, so his force is 85 times gravity. Let's say we're going to use this. Let's use 2. He's got 850 newtons acting there. Because he's hanging on the end of the ring, we have a distance. That creates a moment. A moment is a force times the perpendicular distance. Okay, the force in this case is 850 newtons times how far away that force is acting. Okay, if I look back at little Johnny here, he is 850 newtons and it's acting at 450 millimeters. That is equivalent to 0.45. Okay, because 450 millimeters and 1,000 millimeters that is equivalent to 0.45 meters. Okay, so down here I've got times 0.45 meters. Okay, so he creates a moment of should be 382. Let me just do the calculator. 850 times 382.5 newtons per meter. Alright? So that is the moment Johnny, or the basketballer, creates on the basketball ring. Okay, so we know that to be in equilibrium, the bolt must create a moment equivalent to 382 meters. Okay, but The bolt isn't the same distance away. The bolt in this case is 80 millimeters. 80 millimeters away. Johnny was 450. That is like 6/8. It's about a sixth of the distance. So in reality, it's going to have almost 6 times the force on it. Okay. So if I say we know that to be in equilibrium, moment 1 is going to equal moment 2. Okay. Let's just say I just found moment 1. Okay, moment 1 is here. Moment 2 is here. Okay, yeah, this is the bolt. Okay, so moment 2 is going to equal 382 Newton meters. Okay, so moment 1 is 382.5, and we know the bolt, that's going to equal force times distance. Okay, and we know that our distance, we don't know force, times 80 millimeters, is 1,000 millimeters in a meter, which is the same as F times 0.08. Alright, so if I do 382, so F 382.5 divided by 0.08 is going to equal our force. In that case, our 382.5 divided by 0.08 equals our magical number of 1.25 newtons. Okay, that means there's 4,781.25 newtons acting on the bolt. And I'm going to draw where that bolt is. That bolt there. That's the bolt. Notice I said it's about 6 times the size, roughly. So if we do, what's he, 850 times 6, it's pretty close. Okay. That is the force on the bolt. That is not the end of the question. I'm running out of screen space, and I'm going to delete that stuff and show you on a fresh page what the next step is. This only found the force on the bolt. Okay, in a force couple, which is what is going on here, you need to check pages 62, 64 in the textbook. Force couple means there is not only a moment going on, but there is a vertical force. Okay, so if I pause it. Okay, so in the previous page on the screen, I found out that force in the bolt was equal to 4781.25 newtons. That was this force acting here. Okay, that is what is in the bolt to stop the moment, moment 1 and moment 2. Okay, the overall force in the bolt must also hold them up. There is 850 going down. Hence, there must be 850 going up to balance it. Okay, so in reality, the bolt has 850 and and 4,781 going in. So we have 2 components, a vertical and a horizontal component. I will demonstrate how you calculate the overall force on the bolt. The bolt has a horizontal of 4781, I'll put it right into order, 4781, 0.25. The bolt also has 850. the result of that is this. Okay, that is the result of those, the red, 850, and the blue, 4,781. The result of those two can be calculated graphically or using the sine rule. I'm going to use the sine rule because I think it's easier. Sine rule states, let me write it in red. So we do, what the fuck I guess, a squared plus b squared equals c squared. If we do 850 squared plus 4781 squared is going to equal, let's call that squared. If you do 850 squared, let's do 850 squared plus 4781 and the square root of the answer is 4856. Step 850 squared plus 47. Basically, we have 2, 3, 8, 2, 8, 5, 1, 4, 5, 6 equals r squared. So if we square root that answer equals r. The square root answer equals r then equals 4,856.2 newtons. Okay, what we've just found there is the overall, the net force on the bolt. Remember I said up here we have 4,700 acting on the bolt inwards horizontally. We also have 850 up. The overall force is a combination of the both. In reality, I didn't really want very much to scale. It would be like this. That's 4,781. That's about 850. And our overall force is that. To find the actual angle, we'll be finding the angle to the horizontal. Would be in there. The actual angle is this angle here, and we can use sine rule. Which would be opposite over hypotenuse. That's sine, so you do or opposite over adjacent either way to find the angle. If you do tan, opposite over adjacent, so if we go tan, the angle equals 850 14781.5. We do that, 850 divided by 478.25 equals shift tan 10 degrees. Okay, that angle is 10 degrees to the horizontal. That also means that to the vertical, the angle here is 80. Okay, because in total it's 90 minus the 10. So you could either write 10 degrees to the horizontal or 80 to the vertical.